All right, so as we take a look here at question number 14, the directions are write the equation in standard form of the line satisfying the given conditions. And they give us a point, -4, comma 0, and they give us a slope of -2. And if you took a look at question number 13 here in the video review series, you'll remember that I emphasized two words. When you're given a point and you're given a slope, we're going to use the point slope form. And you'll recall that the point slope form is simply y minus y1 equals m times the quantity x minus x1. And since we've been given a point, let's go ahead and label this point x1, y1. And this x1, y1 from our given point is going to be the x1 and y1 in our point slope form. And the m we're given, the slope we're given, is going to be the m in the point slope form as well. So we're just taking this given information and plugging it into the point slope form. So let's go ahead and do that and see what we get. So we have y minus y1, which we're saying is 0, equals m, -2, times the quantity x minus, and now -4. All right, let's go ahead and clean this up just a little bit. So we have y minus 0, well, that's just y, right? Because this 0 kind of goes away, equals -2, and we'll go ahead and clean up inside the parentheses here first. So we'll do every step. So x minus a -4, well, when we distribute that negative through, we really end up with x plus 4, don't we? And so one more step here. We'll go ahead now and distribute this -2 through. We have now -2x, -2 times x, -2x, and now -2 times +4. Well, that gives us a -8. But the directions tell us they want us to write this equation in standard form. And the way that we have this equation written is in slope-intercept form. And so if we want standard form, we want to go to ax plus by equals c, meaning we want the x and y on one side and the constant, that number without a variable, on the other. And so to do that, all we're going to do is we want to move this x from the right-hand side to the left-hand side so that the x and y are on one side. And we'll go ahead and add 2x to both sides, and that's going to give us 2x plus y equals -8. And now that we have our x and y on one side, our constant on the other, we have successfully written the equation in standard form of the line satisfying these given conditions. Let's go ahead and actually take a look at the next problem, number 15, because it's the exact same directions. Write the equation in standard form of the line satisfying the given conditions. Again, we're given a point, we're given a slope, and so we should be thinking to use the point slope form. All right, and again, I'll go ahead and write it just so we can get used to seeing this. So y minus y1 equals m times the quantity x minus x1. But here we actually have a unique situation because the slope that they are giving us is undefined. And you'll recall from earlier in the practice review series, we talked about lines that have undefined slopes and lines that have slopes of 0. These are maybe, I wouldn't say they're special lines, but they're lines that you want to be aware of because when you see them, when they occur, they tend to have less work involved, because a line that has an undefined slope is going to be what kind of line? Do you remember? Well, hopefully you said vertical. And because the line goes through the point 7,6, you'll recall that when we actually took a look at some of the examples for horizontal and vertical lines, with a vertical line, the only coordinate that is changing in a vertical line is going to be the y value. And so when you have a line with an undefined slope, whatever the given x value of that point is is going to really be the equation of your line. So in this case, the equation of our line written in standard form is going to be x equals 7. And sometimes it is helpful to kind of see a visual. So I'll draw a quick little graph here so that we can maybe visually see why this is the case. So they're telling us that the equation of this line, the line they're giving us, goes through the point 7, 6. So we can pretend, let's see, 1, 2, 3, 4, 5, 6, 7, and maybe 6 is somewhere up here. And since the line has a slope that is undefined, again, we know that it's going to be a vertical line. And so the only point on, or the only coordinate rather, that is changing on this line is going to be the y value. Every single point on this line has the same x value. So here our given point was 7, 6, but if we drop 1 unit, well, now we're at what? Well, we're still at 7, but now we're at 5. And similarly, if we go up 1 unit, well, we're still at 7, but now we're at 7 for the y. And so the only thing that's changing is the y coordinate, but the x coordinate stays the same because the line is undefined. And so when you are given a point with an undefined slope, right away go right to the x coordinate, and whatever that x coordinate is becomes the equation of your line. So simply write x equals and then whatever that x value is. Similarly, if they said that they want us to write the equation in standard form of a line satisfying the given conditions through 7, 6 with a slope of 0, so through 7, 6 and a slope of 0, well, right away we know that all lines that have a 0 slope are horizontal, and so we would go right away, look to see what the y value of this point is, and that would become our equation. All right, so these two examples here, when you have an undefined slope and you have a 0 slope, really don't require any work. Depending on what your slope is, you're going to either go to your x value or you're going to go directly to your y value, and that particular value, whatever it is for the given point, becomes the equation of your line.